Hello everyone and welcome to today's lesson of 10.1.3. Okay, today we're going to be working on this problem, 10.1.3. And for today's lesson, we really need you to see this in front of me. So let's go ahead and look at today's problem. How much should it cost? You have a choice of purchasing a small or large serving of popcorn at the movies. A small popcorn comes in a cone and costs $1.50, and a large popcorn comes in a cylinder that costs $3.50. Both containers have the same height and have bases with the same circular area. Based on their prices, discuss with your team which container of popcorn you think is a better deal. Please be prepared to share your reasons with the class. So what I'm going to do is I'm going to take you through a discussion. And as I take you through this discussion, we're going to be working on these problems right here at the bottom of your page. Now, I have two different cylinders just to show you that there's a relationship that we're going to be discussing. Notice I've got this fluorescent green and I've got this blue. And I want you to notice with both of these pairs, just like the directions mentioned, they have the same height and they have the same diameter. If you'll notice, the diameter of the circle is the same on both sets. Okay, and there's a relationship here. So here we go. Please remember, if at any time you need to write down what we say, please pause the video so that you can go ahead and write down the information. So question letter A. Before we do anything here, how are the radius and the height of each cone related to the radius and height of each corresponding cylinder? How is the cone related to the cylinder? So what did we say about their radius? That's 2 radius make a diameter. Well, the diameter is the same. That's right. So the diameter is the same and therefore the radius is the same. So what you need to do, problem letter A, they have a matching radius. And then if I look at my height of the cone and the cylinder, I can also say that they have a matching height. So to answer our question for letter A, they both have a matching radius and height. And I want you to notice that in both of my examples, that is true. They have a matching radius and a matching height. B, sketch each cone and cylinder on your paper and estimate which one will have a greater volume. You don't need to sketch this because you already have a cone and cylinder here on your paper. And the question is, which do you think is going to have a greater volume? Okay, you can answer that question down in letter B. And the question is, which of these? Okay, is it going to be a different situation? If I change the cylinders, is it going to be a different situation? So go ahead and answer which one you think is going to have a greater volume, the cylinder or the cone. Okay. Part C, this is where we really get to do something. It says, how many cones full of rice are needed to fill each corresponding cylinder? So this is where we have to think. Okay, if I use this cup, many of you should have said that the cylinder is going to have a greater volume. But the question is, how many times greater? Does that look like 2 times as much? 3 times as much? 4 times as much? So here's today's experiment. How many scoops of the cone fit inside of the cylinder? So here we go. Now, I know that our problem says rice, but I have beans. So here's 1 scoop, it's to about here. So how many more scoops am I going to need? Try not to spill any beans. Sorry, bad humor. Okay, there's 2 scoops, and here, do you guys miss my bad jokes? Do you miss my bad jokes? Okay, here's the 3rd scoop. Try not to spill. There we go, pack them in tight. So I want you to notice it took 3 scoops of the cone to fill the cylinder. Well, let's see if that is a different situation if I change cone and cylinder. So here we go, scoops. 1. 2. Nice, even, right up to the top. Okay, and I want you to notice, in both situations, it took 3 scoops of the cone to equal the cylinder. So right here, see how many cones full of rice were needed to fill each corresponding cylinder. 3 scoops. 3 scoops. So based on this demonstration, describe how the volume of a cone compares to the volume of a cylinder if their heights and base areas are equal. So here's the trick. Let's slide this out of the way, or maybe not. All right, here we go. On your papers, I want you to write cylinder. And over here, I want you to write cone. So here's what we know for sure. They both have a circle base. And therefore, if they have a circle base, the area of the base is going to equal pi r squared. Pi r squared. That's how you find the area of a circle. You take the radius, which is halfway across, you square it, which means multiply it by itself, multiply it by pi. That gives you the area of the base. Now, in a cylinder, in the previous lesson, we learned that if I take the area of the base and I multiply it by the height, I find the volume of this cylinder. So I know in a cylinder, it's multiplied by the height. And these have matching heights. So I'm going to do that exact same thing with my cone times height. But here's the extra piece. If this is 3 times larger, then the cone is how many times smaller? 3 times smaller. So if you are going to take something and make it 3 times smaller, you could divide this whole thing by 3, or you could call it 1/3 of the size. Okay? This is the formula for finding the volume of a cylinder and the volume of a cone. Okay? They have very similar situations. They have a matching base. They have a matching height, except the cone is 1/3 of the size. Okay? So, based on that, we can go back to this problem. Okay? This problem is asking us if this small costs $1.50. And this large costs $3.50. Okay? And what we learned is when you buy a small, how many times bigger is this cylinder? This is 3 times the size. So if this is 3 times the size, are you paying 3 times the amount? Well, if I multiply this by 3, I get $4.50. Well, that tells me that in this problem, this large is a good buy. Because if I buy 3 smalls, I pay $4.50, but I get the same popcorn as a large. And buying a large saves you $1 and gets you the same amount. So I want you to go ahead and write a sentence that says that the large is a better buy because it's 3 times the size of the small, but it costs $1 less than 3 smalls put together. Okay? If you need to pause to finish writing that up, please pause the video now. We are going to go to the next page, 10-34. Looks like this, 10-34. 10-34, based on the relationship you found in 1033, determine what a fair price would be for the cylinder of popcorn for 1032 if the cone of popcorn costs $1.50 as the advertised prices, which popcorn is the better deal. I think we just summarized this in 10-32. I think technically we could have written this down under there. What you should write here is that the cylinder should cost $4.50, but only costs $3.50. Okay? That's what this problem is asking you to do, but I would rather you write it down on 10-32. 10-35. Okay? A different movie theater doesn't like cylinders and cones. So I'll go ahead and get my cylinders and cones out of the way. And instead, they like rectangular or square base, okay, and pyramid cups. So here we go. A different movie theater sells popcorns in the container shown below. This time, the small container is a pyramid priced at $2.50. The large container is a prism with the same height and base as the pyramid, and it is priced at $5.50. At this theater, which popcorn do you think is a better deal? Be prepared to give your reasons for your prediction. So once again, I'm going to lead you through, okay, a demonstration here. And once again, we have the question, how many scoops is going to fit in the prism? How many scoops is going to fit in the prism? I have 2 examples here, 2 different models, so that you can see that I'm not just making this up, okay? So, decide if you need to adjust thinking about the relationship between the volume of a pyramid and a prism that have the same base and the same height. So once again, if you look at the openings, okay, they match. They have equal side lengths, and they have a matching height. They have a matching base, okay, and a matching height. Now with that information, we're going to go ahead and start by writing on your paper. We're going to write the word prism, and we're going to write the word pyramid. Pyr with a A. Pyramid. That's right, guys. I still struggle to spell. Here we go. How many scoops? 1 scoop equal? 2 scoops? 3 scoops? 4 scoops? 5 scoops? Make your predictions now. Okay, here we go. We'll go ahead and start with the smaller object. Okay. Here's 1 scoop. down to about here. 2 scoops, down to about here. Okay, here comes the 3rd scoop. Okay, once again, I want you to notice, level on the top, 3 scoops. Well, maybe it's just the pyramid and prism you're using, Mr. McCoy. Let's go ahead and, now this is my type of jumbo popcorn. That would be yummy. Okay, so here we go, scoops. I gotta scoop it a little bit differently here. All right, 1 jumbo scoop. This is not a small. Okay, there's 1. Here comes 2. Oh, that is a lot of beans. Here comes the 3rd scoop. All right, scoop number 3. Whoop. I got a little over generous with one of my scoops. Flatten that out. 3 scoops. So, I want you to notice that once again, our relationship is 3. 3 scoops filled it up. So in a prism, this prism has a base, which if we called this base, we could call it length times width. But in this problem, the length and the width happen to be a square. So I am going to call this L, length. Length. Let's make that look like an L. Length squared. Okay? That is the length. Some people would want to use width, except it's a square, so they've got to be the same. Now I want you to notice that they have a matching base. So the same thing happens over here. Length squared. And once again, they have a matching height. Because they have a matching height, I'm going to multiply it by the height. They both have matching. Everything is the same so far. Except what we just learned, this prism is 3 times larger. The pyramid is 3 times smaller. Therefore, if the pyramid is 3 times smaller, I could divide it by 3 like this. But most of the time, you will see it like this. It is 1/3 the size of a prism. So the pyramid's volume can be found that way. A prism can be found using this formula. Okay? So let's go ahead and determine which of these is the better deal. Now, I'm going to be referring to 10-35, but if you need more room to write down at the bottom, you could write your answer down here. You could write it down here. So let's think here. This prism is a small. How many scoops of popcorn would it cost to fill that up? It would take 3 scoops. So if it would take 3 pyramid scoops, 250 times 3 equals 750. Same amount of popcorn, but notice the price difference. So which one would you want to do? Which one would you want to buy? Which one is a better deal? Let's go ahead and write that our prism of popcorn is a better deal because it should cost $7.50. However, it only costs $5.50. Okay, that is the conclusion of our demonstration of a prism and pyramids, cones, and cylinders. The key factor that you need to remember is that both cones and pyramids are 1/3 the size. That's the key from today's lesson. Now, there are a couple problems that go along with review and preview out of 10.1.3, and you will be able to use homework help on those. Thank you guys for tuning in to today's lesson, and we'll talk to you soon.